All right. Next up, we've got objective 58, solving radical equations. This is the second to last objective for the unit. Objective 59, though, is just special cases of solving radical equations. So really, conceptually, this is pretty much the last thing that we're going to be learning this unit, and then we'll begin talking about review. So, objective 58, solving radical equations. I want to start off by just giving you a few examples of equations and how we would solve them for x. So looking at this first one, we have x minus 4 equals 8. Right now, what's attached to the x? We have a minus 4. In order to get x by itself, we have to do the inverse operation. We add 4 to both sides. So the minus 4 and the plus 4 cancel. We have x equals 8 plus 4 is 12. So x equals 12. Here we have x plus 2 equals 5. We have to subtract 2 from both sides. These cancel. You have x equals 5 minus 2, which is 3. Next up, we have 3x equals 9. We have 3 times x. So in order to get x by itself, we divide by 3. 3's cancel. We have x equals 9 divided by 3, which is 3. And last but not least, we have x divided by 4 equals 2. So in order to get rid of that divided by 4, we have to multiply by 4. These cancel. We have x equals 2 times 4, which is 8. So how did we solve each of these equations? When we had x minus 4, we added 4. We had x plus 2, we subtracted 2. When we had 3 times x, we divided by 3. And when we had x divided by 4, we multiplied by 4. We use what's called inverse operations in order to solve for x, or the opposite operation, right? So when we're solving radical equations including square roots, we're going to use the inverse operation. So what is the inverse operation to a square root? The inverse of a square root is raising to the second power. And in math, we've got a special name for that. We call that squaring. So the inverse to the square root is squaring. And likewise, the inverse to squaring is the square root. But particularly, we're going to be looking at the square root, and we're going to be squaring in order to solve for x. So let's talk about some of the steps that we follow to solve these equations. First, we want to get the square root by itself. So just like how we would solve for x, we would get x by itself, we want to get the square root by itself. So what that means is we have no numbers in front or outside. So we want just the square root on its own side of the equation. So looking at this here, well, we've got 2 times the square root of x plus 4 minus 8 equals 6. In order to get the square root by itself, we first have to add 8 to both sides. And we have 2 times the square root of x plus 4. The minus 8 and plus 8 cancel. We have 6 plus 8 is 14. And then we divide by 2. So the 2's cancel. We've got the square root of x plus 4 equals 14 divided by 2 is 7. So now we've got the square root by itself. There's no numbers on the outside and there's no numbers in front of it. Step 2, in order to cancel the square root, we need to square both sides. And as a reminder, squaring is taking the second power, or it's an exponent of 2. So returning to our example, we've got the square root of x plus 4. In order to get rid of that square root, we're going to square both sides, or raise both sides to the second power. So the square root and the square, they cancel one another out. They're inverse operations. So all that's left is what's inside, is x plus 4. On the other side of the equation, we have 7 squared, or 7 times itself 2 times. 7 times 7, which is 49. Step 3 is we just solve for x as usual. All right. So here we've got x plus 4 equals 49. The last step is we subtract 4. Oops. Subtract 4. And these cancel, and we have x equals 49 minus 4 is 45. All right, let's get a few more examples in. So on the next page, here we've got a square root of something equals a square root of something. So this is another special case of solving radical equations. So when you have, we'll just make a note of this, when you have a square root equal to a square root, then you can just square both sides. Of the equation to get rid of the square root. So when you have a square root equals a square root, you can just square both sides to get rid of the square root. So looking at this one here, we've got the square root of 2x plus 14 equals the square root of 5x minus 4. We're going to square both sides to get rid of the square roots. So on the left side we'll square it, on the right side we'll square it. We get that these cancel, so we're left with 2x plus 14 is equal to, these cancel, so we have 5x minus 4. Step 2 is we solve as usual. So whenever we're solving where we've got variables and numbers on both sides, pick a side for your variables to be on and pick a side for your numbers to be on. Doesn't matter which, but just stick with it. So we'll just say we'll have our numbers on this side and we'll have our variables on this side. So in order to move this 2x over to the other side, we're going to subtract 2x from both sides. So on the left-hand side, we're just left with 14. On the right-hand side, we have 5x minus 2x gives us 3x. And bring down the minus 4. And then we got to move this number over to the other side, so we're going to add 4 to both sides. So then we have 3x equals 14 plus 4 is 18. And then our last step, we divide both sides by 3, and we have x equals 6. And that is our solution. Let's try a couple more. So here, we're solving for x. This is kind of like that first example that we looked at. We've got a square root on one side and there's a few things attached to it. So the first thing that we do here is we subtract 4 from both sides. So on the left hand side, what's left over is just 3 times the square root of x minus 2. And on the right hand side, we have 22 minus 4, which is 18. Next up, we divide by 3, divide both sides by 3. So we have the square root of x minus 2 is equal to 18 divided by 3, which is 6. Now we've got the square root by itself, so we have to square both sides to get rid of that square root. So we're going to square both sides, or raise to the second power. So this square root and the squared cancel, so we have just x minus 2 on the left-hand side. On the right-hand side, we have 6 squared, which is 6 times 6, which is 36. Our last step, we're going to add 2 to both sides, and we have x equals 36 plus 2, or 38. All right. Example B, we've got, this one looks pretty similar to the second example that we looked at. So we've got a square root equals a square root. So in order to get rid of the square root equals a square root, we can square both sides. We square both sides, and we have x plus 5 equals 4x minus 25. Again, we pick a side. Which one do we want the variables on, and which side do we want the numbers on? We'll say we'll put the variables over here, and we'll put the numbers over here. So in order to get the x's over here, we're going to move this one over. So we're going to subtract 4x. So x, 1x, minus 4x is negative 3x. And then we'll bring down the plus 5, and we'll bring down the minus 25. Then we want the numbers over here, so we got to move this over to the other side. So we subtract 5 from both sides. So we have negative 3x equals negative 25 minus 5 is negative 30. And then the last step, we divide both sides by -3. So we have x equals -30 divided by -3 is a +10. And that is our solution. So again, we want the square roots by itself. Then we square both sides to get rid of the square root. And then we solve as usual. So this is objective 58.